Good morning, everyone. It's our channel STEM Masters, and today we start a cycle of videos about solutions for paper 1, round 1 papers of British Physics Olympiad from year 2017 up to 22. So, let's start. Today we'll solve first two problems, A and B. So let's start from A, because it's easier one, because first is usually easier one. We have that physics sometimes use approximations. Light speed, like in vacuum, is 1 foot per 1 nanosecond. So we have to find percentage error. We have original value from table that equal to 3 to the 10 to the 8 meters per second. That is equal to, because we divide over 1 billion or 10 to the power of 9, 3 to the 10 to the power minus 1 meters per nanosecond. So we have speed. Speed is equal to 1 foot per nanosecond. 1 foot is equal to 1/3 of a yard. So we have that it's equal to 1/3 of yard per nanosecond. So that is equal to 1 over 1,094 multiply 1/3 and meters per nanosecond. That we can use calculator, and it is 3.047 to the 10 of the power minus 1 meters per nanosecond. So it's obviously it's bigger, so I think it's actually bigger, so percentage error is positive. So in this case, percentage error is equal to its difference of values over original value. So it's equal to b minus c over c, that's equal to 3.047 minus 3.000. We can put 10 to the minus 1 here, meters per nanosecond, over original value, 3000 to 10 of minus 1 meters per nanosecond, because it's like error is ratio, because percentage is ratio, so it's unitless, so it cancels, and using calculator we receive 0.01564. That is equal to approximately, choosing the figure, it's 1.6%. So, task 2. Let's start. It's like more classical physical task, so we need diagram definitely. We have ladder, and this ladder, like, there is weight that acts on it, and there is force that acts on narrow end that 18 Newtons tries to pick up it. So let's draw diagram. Let's AB. A is wider end, B is narrow end, center of mass. We assume that it's closer to A than to B because it's wider, so there is more matter here. Is it visible from picture? So weight acts on center of mass is weight, and force that acts on the narrow end, it's F. So we also have length. L is equal to 5 meters, and let's draw it like L1 is the distance from wider end to center of mass, and L2 is distance from narrow end to center of mass. So we have to find L2. Let's use like equation of net torque, because we see there is no any angular acceleration, and we can like model the situation like a rotational of rigid body. So let's assume that axis of rotation in this case in I is A. So we have that net torque is equal to 0. So we have torque 1. It's a torque from weight, because there are only two forces, and it's quite obvious they act against each other, because otherwise they both should be 0. So torque 1, it's weight, multiply L1, so it's weight L1 is equal to 350 newtons per L1. So torque 2 is equal to F multiply L, because its axis is rotation. FL is equal to 80 newtons per 5 meters. It's equal to 4 400 newtons per meter. What now? We have that 400 newtons per meter minus 350 newtons per L1 is equal to 0, because there is no angular acceleration again, so the torque is 0. It's like this first Newton law. So we have that L1 is equal to fraction 400 newtons per meter over 350 newtons, and it's good because both units will produce meters that we need. It's 8/7 meters. It's equal to 1.14 meters. But it's not what we seek. We seek for L2. L2 is 5 minus 1.14. It's 3.86 meters. So it's first task we solved. Now II. Let's draw the same diagram, absolutely the same, except forces, because it's our center of mass, it's still weight, but force axis is today from wide end, so it's here. L1, L2, F, and axis rotation this time is V. We use the same balance of torques. So we have that net torque is again equal 0, torque 1 is again weight over this time L2, because distance to the axis L2, so it's 350 L2. Let's leave it now as it, because L2 is not a very pleasant number. Let's use it later. And we have torque 2 is equal to F over L, full length, it's 5F. So 5F minus 350. In this time we can multiply 3.86 is equal to 0. So let's move it to right part of expression. It's like basic algebra. Now we divide over 5. F is equal to 70 over 3.86. It's like newtons. No. Yeah, it's newtons. Meters over newtons. Because meters, because there's 5 meters over meters. So we have it's equal to approximately 270 newtons. So that's it. First task are solved. We continue in next video. Thank you for your views.